Hey everyone, welcome to our second day of online class. Today we're going to be covering lesson number 12, and this is actually the first lesson of the final third of our class. We've already taken exam number 1 in class. Exam number 2 is currently available on my math lab, so that will be over pretty soon for all of you. And then we only have one more exam before the final, and that would be exam number 3. And so today's lesson is the first lesson that covers exam number 3. So, all right, so today is all about decimals. We're gonna do a lot with decimals. I don't know if that's a good or bad thing, depends how you feel about them. But I would say if you have a calculator, I would maybe have that handy as we go through this lesson, and certainly when you do the homework, the lesson 12 homework, because as you know, calculators create shortcuts and also help with accuracy. So, all right, let's talk about decimals. And before we talk about many different little things about them today, let's first make sure we understand the place values for decimals. All right, so way at the beginning of the semester, we actually talked about place values for regular numbers, whole numbers, and we talked about the ones, the tens, the hundreds, the thousands place. So now that we're talking about decimals, we need to know even more place values. And so I'm just going to give you kind of a made-up number here. You can copy this if you want. 5.317642. I'm trying to make sure I pick digits that are all different so that when I refer to them, there's only one of them up here. Okay, so you guys already know that this right here is called the ones place. Again, we talked about that at the beginning of the semester. Anything to the left of the decimal, the first number there would be the ones position, and then going left even more, it would be tens, hundreds, thousands, okay, etc. But now, after the decimal, the very first position after the decimal, and I have seen some people write ones place for this. They get a little confused. There is no such thing as that. So the very first decimal place that we have is actually the tenths place. So right to the right of the decimal, that first place value is called the tenths place. And so then after that, we have the hundredths place. And that's spelled just like hundred, and then you just add THS, hundredths place. And then the number 7 there, that's your thousandths place. Thousand, THS, thousandths place. And then if you keep going, of course, we have here our 10,000ths place, 10,000ths, and then we have 100,000ths. If you keep going, 100,000ths. Notice, by the way, it's not hundredths thousandths, it's just 100,000ths. I've seen that mistake before in the past as well. So just be careful on something like that. You only put the THS at the very last word if there's 2 words. And then the furthest we really need to go here is the millionths place. All right, so the millionths place will be the last one. There may be some questions in the homework that do ask you, when we get to rounding, we'll get to that in a minute, that might ask you as far as the 100,000ths or the millionths place. So I just wanted to make sure you guys had all of that written out. So, okay, so there's the place values, and now let's move on and talk about decimals in standard form, and then how to convert those into fraction form, and then also how to convert that into words, because you're going to see several questions in the homework that look like this. And sometimes they're going to give you a table. So I'm actually going to make the entire thing in a table. So let's make our first column. There's going to be 3 columns. The first one will be decimal in standard form. Okay, decimal in standard form. And there's nothing fancy there about the phrase standard form. It's just decimals as you know them. All right, so decimal in standard form. So we'll make that column. And then the next one will be fraction form. Fraction form. And I'll say or mixed number, because this is possible. Okay, so fraction form or mixed number. And by the way, these fractions do not have to be simplified. So maybe I'll even put that in parentheses, not simplified necessarily. They could be simplified, but they don't have to be. The directions are not asking us to simplify here. And if they're not asking us to simplify, we don't have to, which is nice. And then our last column here, The one that hopefully I saved the most room for is writing it in words. I'm going to move this a little bit over. Okay, so here's an example of something you could see in the homework, the lesson 12 homework. They might give you a decimal like this. They could say, okay, 0.8. How do you write 0.8 in fraction form, and then how do you write it in words? They want it both ways. Okay, so if you look at 0.8, you want to ask yourself, what decimal place is this 8 going to? In other words, what's the furthest decimal place this goes to? And so since there's only one place value here, this is the tenths place, right? We just wrote that up here. This is the tenths. So that means that this is going to be 8 over 10. Okay, 8 tenths, right? The tenths place. Okay, so that's how you would write it as a fraction. And then if you were writing it in words, you just have to write it out 8 tenths. Okay, I always feel like when I'm writing these out in words, I feel like I'm writing a check or something. So, so you just have to basically write the words out, write the numbers out in words. Okay, so then the next one, 0.51. They could give you something like this, 0.51. There's your decimal, and they may ask you for that as a fraction or mixed number. All right, well, this one, again, you want to ask yourself, how far or how many decimal places do you go here in this number? Well, we go 2 decimal places, and so that means we go all the way to the hundredths place, right? The hundredths place. So that means the answer for the fraction here would be 51 hundredths, right? 51 over 100. And so then, of course, if you were going to write that out, you would write it like this, 51 hundredths. Okay, so 51 hundredths. All right, let's try another one. This one tends to be tricky for people. 0.009. I've definitely seen some kind of crazy things. When you have a situation like this, those zeros do matter. When you have zeros to the left of any numbers that are not zeros, like for example here, you have a 9, this is not a 0. Since you have zeros to the left of that 9 after the decimal, those zeros matter. They matter for position. You can't just cross them off. The only time you can cross off zeros, and we will get to that in a second, is when you have zeros at the end of a decimal. If there were zeros after this 9, if there were just a bunch of zeros, you could cross them all off. We don't care about zeros at the end, but we do care about zeros that are in front of or to the left of other numbers. All right, so in this case, we have 1, 2, 3, 3 place values. And if you look here, 1, 2, 3, 3 place values means we go to the thousandths place. So this is just 009, which by the way is just the same thing as 9. You don't need to write the zeros, just 9 over 1,000, right? 9 thousandths. 9 thousandths. And so that's how we write it in words, 9 thousandths. Okay, so I know that gets a little confusing because I just told you guys the zeros do matter, but then when we write it as a fraction, the zeros are gone. And honestly, if I was giving you a test that was in class on paper and pencil, and if you put a 009 over 1,000, I wouldn't mark it wrong, but my math lab might. So let's just not do it because the number 009 isn't really how we write the number 9, right? So just leave it as a 9, and that way you won't have any my math lab issues. They won't mark anything wrong. So just leave it as that. When I say that these zeros matter, what I mean is the position. The position matters. You have to count them as place values. That's what I mean. Now for your answer, you don't have to put them there because 009, as we said, is just 9. Okay, so there we go. All right, let's try one like this. Let's try another one like that. Again, I'm going to try to give you guys one of every single type of situation you could possibly see in the homework and even on the upcoming quiz, quiz number 6. There's going to be some of this stuff on that quiz. So I just want to make sure we cover all of our bases. So here's another example where we do have a 0, but again, this 0 does matter positionally because it's telling us that we have 1, 2, 3 place values that we need to worry about. 1, 2, 3 means thousandths, and so for this one, the answer is going to be 72 thousandths, right? 72 thousandths. And so if we write that in words, 72 thousandths, 70-2 thousandths. Sorry, it's a little messy. Hopefully you can see that I'm trying to wedge it in, running out of paper there, but okay, good. All right, how about one like this? 7.5 7.03. We haven't done one like this yet. If you'll notice, and we didn't draw a lot of attention to it, but here where it says fraction form, it says or mixed number. And that's because sometimes you might get a mixed number here in this column. And here's our first situation where that happens. All right, you have a 7.03. That means that if there's a number to the left of the decimal, that number is your whole number, because that's not part of the fraction or part of the decimal, right? That's just a regular old 7 in the ones position. It's a 7. So that means our answer is going to be 7 and something over something. Okay, so we're going to start off by writing a 7, and then you want to look at your place values here, and you say, okay, we've got 2 of them, 1, 2, tenths, hundredths. We're going to the hundredths, so that means it's going to be 7 and 3 over 100, because it's hundredths place. Okay, good. So this is how you would write your answer as a fraction, or in this case, a mixed number. And so then writing it out, you're going to write 7 in words. You're going to write 7 and 3 hundredths. I'm going to go on to the next line because I can't fit it. Okay, so 7 and 3 hundredths. That's how you would write it out. All right, so let's do maybe one more like that just to make sure we feel good about these mixed numbers. 11.03090. Now, I'm also throwing something out at you guys that's new in this problem as well. Not only can you tell this is going to be a mixed number because we have numbers to the left of the decimal, this 11 here is in the ones position. Actually, it's in the tens and ones position. We've got a 1, 1. This is a whole number, so this is going to turn into 11 and something over here for our mixed fraction. But I told you a moment ago, I'm giving you something new in this problem, and I am, because if you look at these zeros, there's only one 0 here that actually is, in fact, completely unimportant. So unimportant that we could just cross it off and pretend like it's not there. And it's not this one, because remember a moment ago I said, if there's anything to the left of a number that's not 0, that matters. So it's not this one either, because we have a 9 here and this 0 is to the left of it. But this 0 right here on the end, if there's any zeros on the end, meaning on the right of any other numbers, if there's just zeros at the end, you can literally just cross them out. And in fact, you would probably want to cross them out so that you get the correct answer. And so now we count the place values. We have 1, 2, 3, 4 place values. So we go tenths, hundredths, thousandths, 10 thousandths. So that means this is going to be 309 over 10,000, because we went all the way to the 10 thousandths place. Right here, that's 4 place values from the decimal, the 10 thousandths place. Notice as well, my number on top, my numerator is just 309. Again, I don't need to put that 0 because it just looks silly. Like 0309 is not really like how we would write that number. So you just kind of drop it when you're writing it as a fraction. All right, so that's how we would write it. And then writing this in words is a huge pain, but let's do it. So it's going to be 11 and 309 and 309 10 thousandths. So that's like a lot of writing. That's a huge hassle, but that is how you would come up with the final answer there in words and writing. Okay, cool. So this kind of should take care of most of what you're going to see regarding going from decimal to fraction and going to words. However, I did notice that there are a couple problems in the homework assignment, lesson 12 homework, where they might give you something in the middle, or they might give you something in this column, and then you have to fill in the other two. So in case you see something like that, I do want to just cover our bases and make sure you guys feel comfortable with that. So what if I give you an example like this? I'm going to give you words, 6 hundredths, and I'm kind of giving you a hard one, to be honest. It might not look hard, but it kind of is. What if I tell you, I'm giving you the words 6 hundredths, and I want you to give me the fraction in the decimal. So you're kind of working backwards in a sense. So if you get to a problem like this, you'll know how to fill this in. 6 hundredths. Well, writing this as a fraction is pretty easy, right? 6 hundredths just means 6 over 100. 6 hundredths. But writing it as a decimal is a little tougher because you know there's going to be a decimal. You know that this is not a mixed number because there is no whole part right here. It's just a fraction. So there's not going to be any number to the left of the decimal, but you've got 6 hundredths. That means you're going to go 2 decimal places, right? The hundredths is 2 decimal places in. But if you look at your numerator, you've only got 1 digit, the number 6. So that means you're going to have to put a 0 in there. Okay, so that's a little tricky, so just be really careful on that. You have to go to the hundredths place, which means you have to go 2 places in. And since there's just a 6 here, that's the same thing as a 0.6, so 0.06. So just be careful if you see something like that. That would be a little extra difficult, I would think, but you could see something like that. And then let me give you one more example where maybe they would give you a fraction and then you have to fill in the other 2 columns. What about something like this? 5 and 63 10,000ths. What if they give you this? All right, so they're in fact giving you a mixed number here. And so what you need to do is write the decimal and write it in words. So it doesn't really matter which one we start with. Let's just get this one out of the way because it's kind of annoying. So this would be 5 and 63 10-thousandths. Okay, so that's a lot of writing, but that's how you would write that. 5 and 63 10,000ths. Okay, and then over here in decimal form, since you have a mixed number, this 5, this whole number, it's going to be 5 point something, right? We know it's going to be 5 point something. And again, I gave you kind of a tricky one, just like the one up here. I'm giving you 63 over 10,000. Well, 10,000 has 4 place values past the decimal. If you look up here at our little chart that we wrote down, 1, 2, 3, 4 place values in, we're at the 10,000th place. So that means we have to go 1, 2, 3, 4. But if you look at the numerator, we've only got a 63 up here. So here's what I would normally ask as a class. So how many zeros does that mean we're going to need to put in right after the decimal? And hopefully you can kind of figure out, well, that means 2 zeros and then the number 63. So it's going to be 5.0063 because again, we had to go to the 10,000ths place, but our numerator was just 2 digits long. So that means we needed an additional 2 digits. So we're going to put these 2 zeros in there first, then the 63. Okay, great. That's going to take care of the first several homework problems that you're going to see. Actually, they're going to look a lot like what we just did here. And now we're going to move into converting decimals into fractions and then simplifying them. So let's talk about how to do that. You can do this by hand or by using a scientific or graphing calculator. And you can feel free to do it either way or both ways. If you'd like to kind of check yourself, do it by hand and then use the calculator to check. Feel free to do it either way. So the directions will look something like this. Write each decimal as a fraction. Each decimal as a fraction. Write each decimal as a fraction or mixed number. Okay, that's possible. Or mixed number. Oh, let me move it this way a little bit. Okay. In simplest form. And I'm going to underline that because that is super important. We have to make sure we simplify at the end. Unless you're using your calculator should do it for you. All right, so we'll talk about the calculator in just a second, but first, let's do some things by hand. Example number 1, we'll start off pretty easy here. We've got a 0.7, and they want you to write that as a fraction or mixed number, 0.7. We kind of already just did this with our chart that we made. So the number 0.7, again, you want to ask yourself, well, how many decimal places, how many place values does this number go? And it's only 1. We only go to the 10th place, right? The 10th place. So the answer for this one is just 7 over 10 because we go to the 10th place. Now, again, you want to ask yourself, can I simplify this at the end? Otherwise you could get the answer wrong. So is there anything you can divide out of a 7 and a 10 besides 1? And the answer is no. So this actually is in fact our final answer, 7 over 10. All right, example number 2, let's try that again. Here's one very similar. This one is just a tiny bit more work. You'll see why in a second. We've got 0.4. So 0.4 is also just 1 place value. It just goes to the 10th place. So this one will be 4 over 10. Again, 10th place means over 10. And so in this one, we would ordinarily be done, but is there something you can divide out of a 4 and a 10? And the answer is yes. And in fact, what is the highest number we can take out? A 2. 2 is actually the highest. And so when you divide a 2 out of the top and the bottom, you end up with 2 over 5. And so your final answer for this one is 2/5. 2/5. Okay. Let's keep going a little bit, and then I'll show you some things on the calculator. Let's do like 2 more. 0.85. All right, 0.85. So now this one is just, again, a little bit different because now we're going 2 place values, which means we're going to the hundredths place. So that means this is going to be 85 over 100. Again, hundredths place means you put it over 100. Okay, so again, you want to be careful not to write that in as your final answer until you ask yourself, can I divide something out of the top and bottom? And in this case, yes, you can. The highest number, in fact, that you can divide out of the top and bottom is a 5. And so when you do that for your final answer, you may want to use a calculator. I don't think too many of us probably have memorized 85 divided by 5. I know I don't, but feel free to use a calculator there, and you get 17 on top, and then 100 divided by 5. Some of us might have that memorized. 20 on the bottom. So your final answer is 17 over 20, and that is completely simplified. All right, let's do one more, and then I'll bust out the calculator. We'll talk about some shortcuts, some things you guys can do to make these go a little faster. So 0.406. 0.406. Now this one has 3 decimal places, and so that means you're going tenths, hundredths, thousandths. Okay, so since it's thousandths place, we know it's going to be over 1,000. And the number is 406, so 406 goes on top. So 406 over 1,000. Now, when you look at this, you might be thinking, oh my gosh, these numbers are huge. And so I'm gonna have to sit there all day thinking of what numbers I can maybe take out of the top and bottom. Well, there is some good news. If you decide to do all of these by hand when you're doing the homework or the quiz, the good news is this. Even though sometimes they will give you some large numbers, almost always you will be able to divide a 2, 3, 4, or 5 out. And usually it won't be anything higher. So just stick to the low numbers. Use your calculator to kind of help you divide things out if you want to. But the good news is you're not going to have to divide like the top and bottom by 74 or something crazy like that, because that would just get super annoying if you had to check all those numbers to see which numbers were divisible. Okay, so here we go. We've got 406 over 1,000, and I'll just tell you, the highest number you can actually take out of the top and bottom here is a 2. You can't do any more than that. And so when you divide a 2 out, on top, you get a 203, and on the bottom, probably some of us can do this in our head, right? 1,000 divided by 2 is 500, and that is, in fact, your final answer for this one. You can't shrink it anymore. Now, if you are having trouble, as always, figuring out what the highest number is that you can divide out of the top and bottom, just remember that you can do it once by dividing a 2 out, and then you can ask yourself again, is there anything else I can take out? You could, try a 2 again or try a 3. And if you're discovering that there's nothing else that can be taken out, then that means you are done simplifying. All right, so let me show you a couple things. Let me start off with those of you that have the graphing calculator. Let's take example 4 as our example for the calculator. So let's take a quick little calculator break here, and let's put in the number 0.406 into the calculator. If you didn't want to do it by hand, I'm going to turn it on. I'm going to put 0.406 into the calculator. Okay, then all I have to do is hit math. I'm going to go math. And then the very top choice there, number 1, has a little arrow and is saying turn it into a fraction is basically what that means. And so you're going to hit enter and then enter one more time. And it gives you 203 over 500, which is very cool. So it gives you the right answer. There might be some glare there, so there you go. It gives you the right answer and it simplifies it all the way for you. So it already divided the 2 out of the top and bottom, which is very nice. So that's how you do it on the graphing calculator. So you're going to hit that math button and pick the first option and hit enter, enter. And then for those of you who have a calculator that looks more like this, again, this is just a piece of paper. I don't have this calculator. I should buy one. But this calculator is very similar to many other ones. Even the Casio is similar anyway. So take some time to explore or shoot me an email anytime if you have any calculator questions. I'd be more than happy to help you with how to use your calculator in any situation that I can help in. So on this, what you're going to do again is you're going to type in 0.406, And then here, this key right here, the F to D, D to F key, this is what you want. This means fraction to decimal, decimal to fraction. So after you type in 0.406, you're gonna go second and then PRB. Okay, that allows you to get this F to D, D to F. And then you're just gonna hit enter. All right, and when you do that, it should give you 203 over 500. It should do it and simplify for you all the way. Okay, so that's how you would do that. So again, for any of you who has a scientific calculator, I would look for a button that looks just like this, F to D, D to F. Sometimes it even says frac to des to frac. You might see some sort of abbreviation like that. Look for that, and sometimes you have to press second to get to it. Sometimes you don't. It depends on the calculator, and that'll help you to go a lot faster on these problems and check yourself to make sure you're doing them correctly. All right, so there's that. Let's keep going here a little bit. Example 5, what if you have something like this? 6.8, here is a mixed number, 6.8. Well, you know for sure that that 6 is just a whole number, so it's going to be 6 and something over something. So right away, you can just copy the 6 down, but it's the numbers that come after the decimal that you have to think about. So here we only have one decimal place. We go to the tenths place, so that means your fraction is going to be something over 10, right? Tenths place. And it's just an 8, so 8 tenths. So your answer looks to be 6 and 8 tenths, but again, you want to make sure you divide out anything you can. And in this case, we can divide a 2 out of the top and bottom. Remember, you're leaving that 6 alone. You're not dividing a 2 out of the 6. The 6 just keeps carrying over, but it's just the numerator and denominator that you want to take a 2 out of. So now it's 8 divided by 2, which is 4, and 10 divided by 2, which is 5. And so your final answer here is 6 4/5. Okay, let's try another one like that where it's a mixed number. How about negative 15.802. I'm throwing a negative in the mix just because I want to show you guys that it's no different. You just have to remember to put a negative in your answer. That's all you have to do that's different for this problem. So for this one, you have a negative 15 as a whole number because it's to the left of the decimal. So that means your answer is going to be negative 15 and something over something, right? This is the part that turns into a fraction, the 802. And so you say, okay, I've got 3 decimal places, tenths, hundredths, thousandths. So that means it's going to be something over 1,000. And the number here is in fact just 802. So 802 over 1,000. And so here, I'll just tell you the highest number you can divide out of the top and bottom is a 2. You can't do any more than that, which is kind of nice. And so your final answer turns into negative 15 and 401 over 500. Final answer. Okay, great. And again, if you're using a calculator, you could have just put in this original number here. You could have just put in negative 15.802 and then use the fraction to decimal key, and it would have given you the final answer here, all simplified, which is very cool. All right, let's do just one more of these. One more of these, mostly by hand. I say mostly because you're probably still using a calculator for some of it, at least like this part here and stuff, you're probably using a calculator. Okay, so 1.024. So for this one, again, we know that this is going to be a mixed number because we do have a number to the left of the decimal. So it's going to be 1 and something over something. And then if you look here, we've got 3 decimal places. This 0 does matter for position because it's to the left of these numbers. So this 0 we cannot cross off. So we say, okay, tenths, hundredths, thousandths. So that means we're going to have 1,000 in our denominator. And so for the numerator, I could put 024, but again, that's not how we write the number 24. The 0 is pointless when you put it in a fraction now. So we're only just going to write the 2 and the 4, the 24. So 1 and 24 thousandths. And then for this one, we can simplify a little bit. And just to help you out a little bit, I'll tell you the highest number you can divide out is a 4. And when you do that, you're going to get 1 and 24 divided by 4, 6. 1,000 divided by 4, 250. Oops, I made a big mistake. That is not the highest number. The highest number was actually an 8. You could take an 8 out. My apologies, guys. I'm sorry, you could actually take an 8 out. I'm not used to that because usually the numbers don't go quite that high, even though that's not that bad. We could have taken an 8 out. So I guess we'll just use my mistake and show you guys how you can actually do it twice and still arrive at the right answer. I guess it's not all bad. I made a mistake here. So yeah, again, you could have divided an 8 out of the top and bottom here and arrived at the final answer. But instead, I thought it was a 4, and then I realized, I can take 2 more out. So I'm going to go ahead and do that. Hope I didn't mess you up there, guys. But we get a 1, and then 6 divided by 2 is a 3 on top, and then 250 divided by 2 is a 125. Okay, now we are done. That's the final answer. We cannot simplify any further. So I ended up taking you in 2 steps there for simplifying when you could have done it in 1. So my apologies for wasting some time there. But again, not all bad to see that you can do it twice. Okay, so I think we'll stop there for that section. Okay, so actually, in looking ahead here at what we have left, I'm going to do 2 more topics with you. I know this is a very long lesson. We have a lot to cover today. I'm going to do 2 more topics with you, and then I'm going to pause the video, and then I'll start 1 more video. Okay, so the next thing you're going to see in your homework is where you have to insert the less than or greater than symbols. Those are coming back. So we're going to insert less than, greater than, or equals to make true statements. Okay, so this is what the directions will look like. Insert less than, greater than, or equals to make true statements. So here's example 1. Here's the first thing you might see. 0.127 compared to 0.123. Now, some of you can just look at this and you know what the answer is. You can just fly through these, but some of us maybe need to kind of break it down. And so that's okay. And so let me just show you kind of a strategy that you can use to be able to tell which one of these numbers is higher. What I usually like to do is just go from left to right and draw arrows for matching numbers that I see until I discover different numbers and then compare the different numbers. Here's what I mean by that. You have a 1 and a 1 here and here, and those are the exact same numbers, of course. So far they appear to be equal, right? So then we keep going. 2, 2, again, equal numbers. So then we keep going. Finally, we see we have a 7 and a 3. So I'm not going to put arrows there. So in fact, what we're doing here is just comparing the 7 and the 3. We don't care about the 0.12 because up until that point, they were equal numbers. But now we've got a 7 versus a 3. And so it becomes very easy. Which number is larger, the 7 or the 3? Well, 7 is a greater number, a bigger number. So that means we're going to put the greater than symbol facing toward the 7. And that's your final answer. Okay, that right there is your final answer. Greater than. The first number is greater than the second number. Okay, so let's look at the next problem. How about this? 0.0756 compared to 0.2. Okay, so the first thing I usually like to do is this. If I notice that the decimal places between my 2 numbers are different, the amount of decimal places, if I notice that they're different, I like to try to make them even. Even if you can tell what the answer is, I just like to make them even just to kind of maintain consistency. So here you've got 1, 2, 3, 4 decimal places. This one only has 1. So I'm allowed to add zeros so that I now have 1, 2, 3, 4. I want to keep these even as far as number of decimal places. Okay, so now they both have 4 decimal places, and I'm going to say, all right, we're going to go from left to right. The first number has a 0. This number has a 2. Okay, so we already noticed they're different. So I'm going to go ahead and circle these numbers. These are numbers that are not the same. And so all you have to ask yourself is which number is greater, the 0 or the 2? And of course, 2 is larger. So this one gets the greater than symbol opening up in this direction. 0 is less than the 2, or you can think of it this way. 2 is greater than, it's opening up this way, than the 0. Okay, good. How about one like this? This one looks bad, but it's really not. How about 0.01 compared to negative 0.1? This can confuse people because it's like, oh man, zeros and ones, that's all we have here are zeros and ones, and it gets a little tricky. Like, Where should I put the 0 in this one to make it the same decimal places as this one? And what are the rules? Well, there's good news. Anytime you have a situation where you have one positive number and one negative number, oops, I already gave you the answer. I did not mean to do that. Oh man, I'm making so many mistakes. Okay, sorry guys. Whoops. So I already wrote the answer out. Didn't mean to do that. But okay, there it is. There's the answer. Let's pretend it wasn't there originally. And so I would ask you guys, which one is larger? So, all right. So here's the deal. Anytime you have one that's positive and one that's negative like this, the one that's positive is always going to be larger. Always, always, always. No matter what, a positive number is larger than a negative number. So that's how you know automatically that this one gets the greater than symbol opening up to it, because this one is negative. You could even put a little note to yourself. If one number is positive and one number is negative, then the positive number, right? The positive is always greater, no matter what. Okay, that is always true. So if you see a situation like that in the homework, if there's one positive and one negative number, you don't even need to look at the numbers. Just know right away the positive number will be greater. Sorry about that, giving away the answer at the very beginning. Okay, there we go. Example number 4. We'll do 2 more then. We'll do this one and then example 5. Negative 0.23 compared to negative 0.24. All right, so in this one, the good news is the numbers aren't that bad, right? There's not a whole lot of digits happening here, not a lot to think about. But this is the first example I'm giving you where both numbers are negative. So you're going to compare these two numbers. Which one is larger? Well, again, going from left to right, you'll notice they both have 2's in common. But then when you get to the next number, you've got a 3 versus a 4. Now, of course, ordinarily a 4 would be larger, right? But when you're comparing negatives, you guys know that it's like the opposite, right? So a negative 3 is actually greater than a negative 4. And so the final answer would look like this. Okay, that would be your final answer for that one. Okay, so just be careful when you have 2 negatives. Okay, when you have 2 negatives, the number that appears to be smaller is actually greater because it's negative. All right, and then let's make this our last one of these type of problems. How about 0.98400 compared to 0.984? 0.98400 compared to 0.984. All right, this one it has an element of trickiness to it for sure. If you look at these two numbers, they have an uneven number of decimal place values. So we want to even the playing field. Here we have 1, 2, 3, 4, 5, and this one has 1, 2, 3. That's it. We're missing 2. Now you have an option here. You could either add 2 zeros on the end. Okay, you're totally allowed to do that. You're not changing the number when you do that. You're allowed to add as many zeros as you want to the end of any decimal. So you're allowed to do that. Or you could have gone to this one and crossed out the 2 zeros, right? So you had 2 options. You could have either added 2 zeros here, or you could have crossed out these 2 zeros, because these 2 zeros do not matter. They're at the very end of the decimal, on the right end of the decimal. So either way, if you use either method, you will see pretty quickly that these two numbers end up being the exact same. They are both 0.984. And so since that's the case, of course, our answer then is equals. We put an equal sign between them. So just keep that in mind as you go through these. I'll also write it the other way in case anyone wanted to write it down or see it that way. These are the same thing as just 0.984 equals 0.984, same thing. So either way, the answer is equals, and that's all you need to know for that one. Okay, great. Let's do one more topic before I end this video, and then I'm going to continue it onto a separate video. Again, a long lesson today. I know this might, in fact, be the longest lesson, though, that we have left for the entire semester, so that's really good news. All right, how about this? Rounding. Rounding is coming back. We haven't done this in a while, and we've never rounded a decimal in our class yet, but we're going to do that now. Round each decimal to the given place value. To the given place value. Okay, round each decimal to the given place value. All right, here's our first example. Example number 1, 0.58, and we're gonna round to the nearest tenth. Okay, so when you get to this section in your homework, they're going to give you a problem and they will also tell you what place value they want you to round to. So they're giving you 0.58 round to the nearest tenth. You might remember when we did rounding before, when we were just talking about regular old whole numbers and integers, and it's the same thing. You do it the same way. So for this one, the tenths place is actually the number 5 here, right? 5 is in the tenths place. And so remember what you have to do. You have to look at the number directly to the right of it. Okay, that's the number we really care about. We have to focus on that 8. And we ask ourselves, is that number that I put in the box a 5 or higher? And the answer is yes, that is a 5 or higher. And so since that's the case, this number here goes up 1. So your final answer is 0.6. Final answer, 0.6. Okay, so let's do a few more of those just to kind of refresh our memory. 0.24, and again, we're going to do the nearest tenth. Nearest tenth. Okay, 0.24 to the nearest tenth. All right, so in this one, I would normally ask you guys, if we were together, I would say which number here is in the tenths position. Hopefully you would say 2, and you'd be right. That is correct. And then what we want to do then is look at the number directly to the right of it, and we have a 4 here. So you ask yourself, is that number a 5 or higher? It is not. So therefore, this 2 stays the same. So your final answer is just 0.2. That 2 does not change. It does not go up 1, and it never goes down 1. Okay, so it just stays the same. Okay, so example 3. How about one like this? Negative, I'll give you a negative. Negative 0.2346, and I want this to the nearest hundredth. All right, so this time it's a negative 0.2346 to the nearest hundredth. All right, so if, again, we were together, I'd say which number is in the hundredths position? And it would be this number right here, the 3, right? That's in the hundredths place. So if you look to the number directly to the right of it, we have a 4. Is that number a 5 or higher? No, it is not. So therefore, this 3 stays the same and it ends there. So your final answer is negative 0.23. Notice in my answer, I'm including the negative. This negative was part of the original problem, therefore it will be part of your answer. And then notice again, I stop at the hundredths place and I just turn it into a 0.23. Everything else goes away because that's how you do rounding. All right, example 4. Example 4, let's do this one here. Let's just do one more. This will be our last one because I think you guys get the idea. Negative 0.997. And we're going to do this to the nearest hundredth. Okay, negative 0.997 to the nearest hundredth again. And so here I'd ask you, which digit is in the hundredths position? And hopefully you would say the second 9 here. And that is right, that's the hundredths place. And so we're gonna look at this number directly to the right of it. And this is a super tricky problem. I purposefully did this in case you see something like this. This would be a tricky question that they could possibly give you. And so this 7 right here is indeed a 5 or higher. So that means that this 9 has to go up 1. But if this 9 goes up 1, that turns into a 10. Technically, that means that's a 0, and then you carry the 1, right? So that's going to turn into a 0, and then you carry the 1 to the next one. And that's going to make this also a 10. So that turns into a 0. And then you actually have to carry 1 past the decimal. So your final answer here is actually -1. If any of you worked ahead of me and did that problem and came up with that answer, great job, because that is not something that I would consider easy by any means. So your final answer here is just -1. Now, if you put -1.0 or -1.00, it certainly is not wrong, but all of those zeros are unnecessary, and I just don't know if my math lab would mark that wrong. So to avoid getting something like that marked wrong, I would encourage you guys not to put the zeros or the decimal if it's unnecessary. All right. Okay, so I'm going to pause there. Wow, 45 minutes almost. I'm going to pause here and I will start the second part of our lesson. The second part will go much faster. So we'll take a break. Here we go.